Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about area between curves.
Minute Math. When you need help, you use Minute Math.
We're given this problem right here. Y equals 2x squared minus 8x plus 10. Y equals x squared over 2 minus 2x minus 1. And x equals 1 and x equals 3. And we want to find the area of the region enclosed by the curves. So we need to set up really just a large integral here. So they tell us here from really it's x equals 1 to x equals 3. So what that tells us, we have our integral here from 1 to 3. Now we want to find the area between curves. We want to find the upper equation and subtract it, or the equation on top basically, minus the equation on the bottom. So to do that, our top equation clearly is our first one, 2x squared minus 8x plus 10. So what we want to do is write that out, 2x squared minus 8x plus 10, and then we're going to subtract the second equation that's below it. That's the x squared over 2 minus the 2x minus 1, and then dx. And now that we have this set up, we just need to solve this integral here, and we'll get our answer. Okay? So the way I like to rewrite this is we'll simplify it first before we take the actual integral. So we're integrating from 1 to 3 here, and we'll combine our like terms. Distribute this minus sign across to all parts here, and 2x squared minus an x squared over 2 is a 3/2 x squared. We have a negative 8x minus a negative 2x is plus a positive 2x, so we have minus 6x right here. Then 10 minus a negative 1 is plus a positive 1, or positive 11 dx. So we're rewriting the integral now, and now we can, take the integral. What's the integral of 3/2 x squared? And that comes out to be a x to the third over 2 minus 6x squared becomes a 3x squared, and 11 becomes 11x. We're integrating this from 1 to 3. Okay? Well, the first thing we want to do, we plug 3 in for x and we solve. And so when we plug 3 in for x and solve, we get a 19.5. Subtract, I did it for you, put a 1 in for x and solved or simplified, and we get an 8.5 here. 19.5 minus 8.5 comes out to be 11. So the area between the curves here, our final answer is 11. We're given these functions here. X equals 2y squared plus 12y plus 19. X equals a negative y squared over 2 minus 4y minus 10. Y equals negative 3 and y equals a negative 2. And we have to find the area between these curves. Now, what's interesting here is my first two equations are with respect to y. And so with other ones, y equals and y equals here, negative 3 and negative 2, we actually want to integrate this with respect to y. Okay? So we're going to start with a lower y value, the lowest y value when we make our integral here. Okay? And that's going to be our integral from negative 3 to negative 2. Okay, the lowest y value. We're going to integrate in that way. Well, the most left equation, okay, the most left equation that we start with is the 2y squared plus 12y plus 19. So we put that in first, 2y squared plus 12y plus 19. And then we have to subtract the right equation, okay? So that is the negative y squared over 2 minus 4y minus 10 dy. Okay? So now from here we want to simplify this integral. Okay? So we're going to rewrite this negative 3 to negative 2 and we combine our like terms. 2y squared minus a negative y squared over 2 is like adding a positive, and then that gives us a 5y squared over 2. Then from here, keep on going, combine our like terms, 12y minus a negative 4y is plus a positive 4y, and we have 16y. Plus 19 minus negative 10 plus a positive 10 is a 29, and we have dy here. Much easier integral to solve here, and well, now let's go integrate this. The integral of 5y squared over 2 is a 5y y to the third power over 6 plus 16y is an 8y squared, and 29 is a 29y. And we're integrating this from -3 to -2. From here, we need to plug in -2 first in for y. And so we plug -2 in for y and simplify, we get a -32.6 repeating. We subtract that when we plug in -3 in for y, and we get a -37.5. Well, -32.6 repeating minus a negative plus a positive 37.5 is a 4.83 repeating. And there we have it. Our area between the two curves comes out to, or all curves, comes out to be a 4.83 repeating. We're given this problem right here. Y equals x squared over 2 minus 3x minus a 1/2, and y equals 3. And we want to find the area between the regions enclosed. Well, one thing we have between the two equations here, we need to find the endpoints where they intersect. And we can clearly see that with the graph. We can check it algebraically, but with our graph we have an x equals a -1 and x equals a +7. And these are the x values where these two equations intersect. So with that being said, we need to create our integral from our lower bound -1 to our upper bound 7. We want to integrate and we want to have the top equation first. Okay, the top equation here being 3 over the interval minus the second equation, the bottom equation, x squared over 2 minus 3x minus 1/2 dx. And we set up this integral now where we can just solve it and get our answer. Okay, the hardest work is just setting it up. So from here, what we want to do, we want to find, well, combine our like terms, -1 to 7, and we can see where we can add things now. But I kind of like to put things in order too. So the first one's the x squared. We have negative x squared over 2, and then minus a negative is plus a positive 3x. And here we can combine our like terms, 3 minus a -1/2 is plus a positive 1/2, which is a 7/2. Okay, dx. Now from here we can find the integral. The integral of -x squared over 2 is a -x to the third over 6. Plus the integral of 3x is a 3x squared over 2. And the integral of 7/2 is just a 7/2 x. And we're integrating this from -1 to 7. From there, we need to plug 7 in for x and simplify that. So I did that for you. When we plug 7 in for x here and simplify it, we get a 40.83 repeating. We subtract that when we plug -1 in for x, and I did that and simplified, and I got a -1.83 repeating. Subtracting negative, same thing as adding a positive. So when we add the two, 40.83 repeating plus 1.83 repeating, we have a 42.6 repeating. And there we have it. My final answer for the area between the curves is a 42.6 repeating. We're given this problem right here. Y equals the -x to the third over 2 plus 2x squared, and y equals the -x squared plus 4x. And we want to find the area between the regions enclosed here. Now, one thing that we aren't given are where these equations intersect. And we can see that on our graph here. They intersect at x equals 0, 2, and 4. So from here, what we want to do is we're going to set up an integral with these values. We're going to integrate between the two functions, basically. And we're actually have two integrals, from 0 to 2, and then 2 to 4, because they switch on which one's on top there. So we need to set this up. The integral from 0 to 2. Between that interval, which one is the higher equation, higher on the graph, and that's going to be the -x squared plus 4x here. So we have -x squared plus 4x. We're going to subtract then this other equation. That's one that's on the bottom here. Okay, and that's a -x to the third over 2 plus a 2x squared. Dx. Then we want to add the second equation here to it. And the second part is from 2 to 4. Okay? And this time, between that interval, the negative x to the third over 2 plus 2x squared is on top. It's a higher equation there. So we write that first. We have a negative x to the third over 2 plus 2x squared minus this other equation, negative x squared plus 4x dx. So now we set up a big integral, two of them, and we need to solve this. Now, same steps as before. Let's take our time. Let's simplify this out a little. Okay, 0 to 2 here, integral. Let's combine our like terms. We have a negative, well, the only one to the third power is this first one right here. So negative, negative, mixed with a positive. We have x to the third over 2 plus, well, we have negative x squared minus a negative 2x squared. So that combines to be a negative 3x squared. And then we just have a 4x left over here, plus 4x dx. Plus, we're going to the second integral from 2 to 4. Same idea, combine our like terms. Negative x to the third power is the only one, the third power, so right from the beginning, negative x to the third over 2. And then we have an x squared. 2x squared minus a negative 2x squared plus a positive, plus 3x squared. And then we just have a minus of 4x at the end, dx. Okay? So now from here, we need to find the integral of each one. Okay? So let's go do that. Well, the integral here of x cubed over 2 is x to the fourth over 8 minus integral of 3x squared is an x to the third power. And then the integral of 4x is a 2x squared. And this is integrating from 0 to 2. Same thing here, we integrate the second equation from 2 to 4. Okay? Negative x to the third over 2 is a negative x to the fourth over 8. Plus integral of 3x squared is an x to the third. And then a minus 4x is a minus 2x squared. And we're integrating this from 2 to 4. So then from here, we want to, well, apply our rules like we always do. 2 goes in for x first. Okay, so when I substitute 2 in for x and simplify, I actually get a 2. And we subtract that by when we plug a 0 in for x, and we get a 0. Plus, same thing here, when we plug a 4 in for x, I did it for you. When I plug 4 in for x, it comes out to be a 0, that's nice. Minus, when I plug 2 in for x in the second equation and simplify, I get a negative 2. 2 minus 0 is, well, a 2. Plus a 0 minus a negative 2 is plus a positive 2, plus 2. And hopefully we all know this, 2 plus 2 is 4. So after all of that, the area of the region enclosed by the curves is just 4. We're given this problem right here. Y equals a negative 2x squared minus 1. And y equals a negative x plus 3, x equals 0, and x equals 1. And we want to find the area between these curves. Okay? Well, we clearly see it's between 0 and 1 with our x values. So to set up this integral, we're integrating from 0 to 1. And we want to find the upper equation and subtract it by the lower equation. Well, our upper equation is the second one, negative x plus 3. So we have a negative x plus 3 here, minus the other equation, the bottom one, negative 2x squared minus 1 dx. Now I like to simplify this before we take the integral, it's just easier. So we have the integral from 0 to 1, and let's combine our like terms. Negative, negative 2x squared is a positive 2x squared. Then we have a minus x right here as the next term down, and then 3 minus a negative 1 plus a positive 1, so a 3 plus 1 is a 4. So now we have an integral from 0 to 1 of 2x squared minus x plus 4 dx. Let's go integrate this. The integral of 2x squared is a 2x to the third power over 3 minus integral of x is an x squared over 2 plus integral of 4 is a 4x. And we're going to integrate this from 0 to 1. Well, I did the hard work for you. I plugged 1 in for x and simplified. And when I did that, when I plugged 1 right in for x and simplified, I got a 4.16 repeating. When we plug 0 in for x, we get a 0. Oh, minus the 0. Well, clearly 4.16 repeating minus 0 is just a 4.16 repeating. And there we have it. My final answer here for the area between the curves is a 4.16 repeating. We're given this problem right here. Y equals 2 times the third root of x squared and y equals x. And we want to find the area between the curves here. Well, one thing we're not giving is the lower and upper bound here. So to do that, we actually set the equations equal to each other and see where they're equal, where they intersect. So I take the, 2, third root of x squared, and set it equal to x. And when does this happen? Well, right off the bat, we can see this happens at, x equals 0, right? 0 for both, they become equal. Easy to see. The second one actually happens when x equals 8. And we can see that here. If we plug in 8, third root of 8 squared equals 8. 8 squared is a 64, so 2 times the third root of 64 equals 8. The root of 64 is a 4, so 2 times 4 equals 8, and I think you get it. 8 equals 8. So that comes with some practice simplifying that, but we have our two values, x equals 0 and 8. And these are going to be the bounds of the integration. The integral from 0 to 8. Now we want to find the upper equation over this interval. And an easy way to do it is plug in 1 in for x and see which one's higher. It's within the interval. 1 in for x is 1 here. Here it's a 2. Got that? 2 is going to be higher. That's the upper equation. So we have a 2 times the third root of x squared minus the second equation, which is x dx. Not too bad. Now, if you're like me, I don't like dealing with integrals with third roots and squares. I like to fraction the exponent. So I'm going to rewrite this from 0 to 8 of a 2 times an x to the 2/3 power minus the x dx, like this. A little easier for me to solve. And so now we want to find the integral of 2x to the 2/3 power, which is a 6x to the 5/3 power over 5. And the integral of x is an x squared over 2. And we're integrating this from 0 to 8. So now from here, we first plug in 8 in for x and simplify. When we get this, when we plug 8 in for x and simplify, we get a 6.4. And then we plug 0, I did it for you. 0 for x gets us a 0. And 6.4 minus a 0 is a 6 point. If I can write it here, 0.4, that's a big decimal point, 6.4. And so there we have it. Our final answer for the area between the curves is a 6.4. We're given these equations here. Y equals a negative x to the third power plus 6x, and y equals a negative x squared. And we want to find the area of the region enclosed by the curves. Well, first thing is I want to see where these functions intersect. Okay? So what I want to do is I'm going to set them equal to each other. Negative x to the third plus 6x equals a negative x squared. And now I'm going to see what x values cause this to be equal. Well, let's solve this. Bring x over the other side. We have negative x to the third plus an x squared plus a 6x equals 0. Now, if you're like me, I don't like seeing things in a negative the first term here. So actually, if I pull out a negative x here, if I pull out a negative x, I'm left with a positive x squared minus an x minus a 6 equals 0. Okay? So now we're going to, see if we can factor this a little bit as well. We have negative x here times this inside part actually factors x squared minus x minus 6 becomes an x plus 2 and an x minus 3. And now we can set each part individually and solve for x. Hopefully you can see that. X equals 0, negative 2, and a positive 3. So we're going to have two integrals here to deal with. Okay? Our integrals will be from negative 2 to 0. So we integral from negative 2 to 0, and then from 0 to 3. So let's deal with the first one, negative 2 to 0. We want to see which equation is on top, which one's on bottom within that interval. Okay? Between that interval, I picked an x value of a negative 1 for each one. So if I can fit this in here, make a little break here. Okay, negative 1 in for x. In the first equation, I put negative 1 for x, and I got an output of a negative 5. The second equation, negative 1 for x, gave me an output of a negative 1. That means negative x squared is above, over that interval, the first equation, negative x to the third plus 6x. So when we write this integral, we have a negative x squared first minus the first equation, negative x to the third plus 6x dx. We're going to do the same thing on our interval from 0 to 3. And I picked another value between 0 and 3 was just positive 1, keep it easy. Positive 1 in for x on our first equation, and I got a positive 5 within that interval. The second equation, I'll plug a positive 1 in, and we get a negative 1. Okay? So that means on this interval, the second one, the first equation here, first equation is the one that's on top. So we rewrite that here to be a negative x to the third plus 6x. Okay? And we subtract this second equation, negative x squared dx. Alright. Now it's a whole bunch of simplification. Okay? So we're going to simplify and combine our like terms. So we have negative 2 to 0, combining my like terms here. My highest term is just x to the third power. We're subtracting a negative x to the third power, adding a positive x to the third power. Then next term is x squared, so we have a minus an x squared here. Then minus the 6x dx. Not too bad, not too bad, not too bad. Second one, integral from 0 to 3, do the same thing. Negative x to the third is the first term. The next one's going to be a positive x squared minus a negative, positive x squared, then plus a 6x dx. So now from here, we need to find our integrals, okay? So the first one here, the integral of x to the third power is the x to the fourth over 4. And the integral of negative x to the third squared is negative x to the third over 3, not too bad. Integral of 6x is a negative 3x squared, and we're integrating this from negative 2 to 0. Same thing here, negative x to the third power is a negative x to the fourth over 4, plus integral of x squared is an x to the third over 3, and the integral of a 6x is a positive 3x squared. And we're integrating this from a 0 to 3 now. So our rules still apply, like always, it's just two different integrals that we need to simplify with. So we first plug in 0 on this first one here, in for x, and that gives us a 0. We subtract when we plug in negative 2 in for x and simplify, and I did that for you, and I got a negative 5.3 repeating. Same thing here with the second equation. We plug 3 in for x, and when we plug in 3 in for x, we get a 15.75. I did that for you. Minus, when we plug 0 in for x, we get a 0. Okay? So now let's go, we'll simplify this. The minus and negative 5.3 repeating is plus a positive, so 5.3 repeating, plus a 15.75. And that comes out to be a good old 21.083 repeating. And there we have it. My final answer here for the area between the curves is a 21.083 repeating. We're given this problem right here. Y equals a negative 2 times secant squared of x, and y equals 2 cosine of x. X equals 0, and x equals pi over 4, and we want to find the area of the region enclosed by the curves. Well, clearly our integral is between 0 and pi over 4, but I don't know which equation is above the other on this interval. So I pick a value within the interval, and I picked pi over 6. And when I plugged pi over 6 into each equation, what was the output? Well, in the first equation, negative 2 times the secant squared of pi over 6, I got a negative 2.6 repeating. On the second equation, 2 cosine of pi over 6, I got a 1.732. And so 2 cosine of x is higher over an interval than negative 2 secant squared of x. So this helps us set up our integral. We're integrating here from 0 to pi over 4. And we have, again, the first equation, 2 cosine of x minus a negative 2 secant squared of x dx. And now I want to simplify this. Well, just to make things a little easier, I like to just get rid of that negative here. So we have the integral here of 0 to pi over 4, 2 cosine of x plus a 2 secant squared of x dx. All right, well, let's let's keep on going here. The integral of 2 cosine of x is 2 sine of x, plus the integral of a secant squared x, or 2 secant squared x, is a 2 tangent of x. And we're integrating this from 0 to pi over 4. Well, first we want to plug pi over 4 in for x and simplify. When we do that, we plug pi over 4 in for x and we simplify, we get a 2 plus a square root of 2. When I plug 0 in for x and simplify, I get a 0. And so now, at the end, our final answer, 2 plus square root of 2, is the area between the curves, the region closed, right there. So again, final answer in square root form. Approximate here is a 3.414 if you want the decimal. But either way, our final answer is 2 plus square root of 2. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.